EcoTrace is a platform for managing digital product passports, enabling the creation, configuration, and visualization of product-related data. It allows users to define flexible data models and generate DPPs based on different product types. Additionally, it provides public access to DPP information through QR codes, ensuring easy and transparent data sharing. Our architecture is structured around a front-end built in Angular, connected to a DPP API responsible for managing digital product passports using a CQRS and event-driven approach. Data is stored in MongoDB, while files are handled through an S3-compatible storage. The front-end application provides a complete interface for managing digital product passports in a flexible and user-friendly way. In this demonstration, we first present the list of reusable field groups, which define the data structure and can be combined to support different product configurations. These are then used to define product types, enabling tailored data models for each category. When creating a product type, the interface supports a hierarchical tree of fields, making it easy to organize complex data structures. Products are then managed through lists grouped by product type, providing a clear and structured overview. Each product is associated with a QR code, enabling quick access to its digital product passport. Finally, by selecting the QR code, the full DPP view is opened, where all the product information is presented in a structured and accessible format. In the DPP API, we receive requests made by the front-end, which can be GET, POST, update, or delete requests. The requests go through a sequence of verification and validation that determines whether the endpoints are public or private, with the latter only being accessible to authorized users. After verification, and if the endpoint is accessible, the service retrieves the requested data from our database. In the case of DPP, after obtaining the data, the service filters it to determine which fields the user in question can view. If the information has associated files, the service retrieves the URL of that file from our file storage. Once the DPP has all the information, it is sent to the front end. For our database, we use MongoDB, a NoSQL database that provides greater flexibility for storing data. The database contains several collections, with the most important for managing DPPs being product type, field group, and DPP. MongoDB stores data records as documents within collections, using a JSON-like format, which facilitates the storage of JSON LD data. To ensure efficient data retrieval and good overall performance, indexes are used in the MongoDB database. These indexes are special data structures that make queries, filtering, and sorting operations faster by allowing the system to locate and access data more efficiently without scanning the entire collection. For file storage, the system uses RustFS, an S3-compatible object storage solution that provides a scalable and reliable way to manage files. File metadata, such as identifier, file name, and content type, is stored in the database, while the file content is stored in the storage service. This approach improves performance and scalability by avoiding the storage of large binary data within the database. Future developments will extend the architecture with blockchain integration and a semantic dictionary repository to enhance data integrity and interoperability. The validation API will be integrated with the blockchain gateway, enabling verification of DPP data against hashes stored on the blockchain. Create, update, or deactivation operations in the DPP API will publish events via Kafka, which are forwarded to the blockchain gateway to store a hash of the data. The validation component will allow the front-end to compare retrieved data with the blockchain record, ensuring integrity. In parallel, a semantic dictionary repository will be introduced as an independent service with its own database and API, providing standardized vocabularies and semantic mappings to ensure consistent data interpretation and support JSON LD usage across the system.